discuss about decision tree regression. So this is one interesting algorithm. Why we need a decision tree is we will use the random forest based on the decision tree regression. So we will learn two algorithms today. I will tell you what is the relationship between decision tree as well as random forest. So CART. What is CART means? Classification and regression techniques. Classification and regression. So it will do both classification and regression trees. So it has both classification as well as regression. We know what is regression and what is classification. Regression means to predict the numerical value. Example, house price, car price, stock price, gold price, etc. It is a numerical value. The output is a numerical value. Whereas in the classification tree, the output is a binary classification. So it is either 0 or 1. Example, whether the mail is spam or not, whether the person has disease or not. So like that, the classification problems will be solved by classification trees. So we have two different types of trees. We will study what is a decision tree with a simple example. So here it is a graph. It is a scatter plot. It has two independent variables, x1 and x2, or we can call that as two features, x1 and x2. It is a scatter plot. You have the relationship between the x1 and x2 has been in the form of scatter plot. Okay, so these are the data points, and we need to predict y. Y is the dependent variable. I will not show. We cannot show y here because the scatter plot that we can see is a two-dimensional one. Okay, if you want to show y, it comes in a three-dimensional. We need a three-dimensional plot. So since it is a two-dimensional one, we cannot see y. But we will understand how we can calculate y with the help of x1 and x2. Okay, so this is basically a scatter plot between two independent variables or two features in a data set. These are the data points. How the decision tree will work? It is working basically by splitting the data sets. Here you have data points here, that red color one. The multiple data points are there. How the decision tree algorithm will work is it will split the data. Okay, here you can see the first split here at x1 equal to 20. So the data points may be x1 greater than 20 or x1 less than 20. So based on this condition, your data set has been split into two. Okay. Similarly, you can have multiple splits here. So here you can see the split 2, where the split 2 taken place is in this area. The condition here is x1 greater than 20 and x2 is greater than 170 or below 170. So here you have another split. Like that, you have another split also here and another split also here. So like that, your decision tree algorithm will split the data set into groups, and you will have multiple groups. How long it will split is each group contains less than 5% of your data set. That is the algorithm. On what basis it is splitting? Okay, so that we have to know. On what basis it is splitting is based on the information entropy. It is a mathematical calculation called information entropy. Based on that only the splitting is occurs. Why it is splitting? The first split occurs at x1 greater than 20 or less than 20 is based on the information entropy mathematical operation. Okay, so using that only the algorithm splitting the data sets into number of groups. That's why it is called. Why it is called tree is we can map this in the tree format. For example, the first split is happening at x1 equal to 20. So there are some data points below x1 equal to 20, x1 equal to 20, and there are some data points above x1 equal to 20. Okay, so how this point has been chosen is based on the information entropy. So we can form a tree. So x1 less than 20, some of the data points will be there, and x1 greater than 20, some of the data points will be there. X1 is less than 20. If it is yes, we have one group, and x1 less than 20 is no, we have another group. And you can see in the next split where this is happening, x1 greater than 20. In x1 greater than 20, we have another split. What is the split? x2 less than 170 or x2 greater than 170. Okay, so in the tree, how it is? In the leaf of x1 greater than 20, you have another decision, that is x2 less than 170. In that, again, it is split into two. So some of the data points may be less than 170 and some of the data points is greater than 170. So here you have less than 170 and you have greater than 170. So this is another leaf in a tree. And one more split is also there. What is that? Split number 3. The split number 3, where it occurs in the leaf x1 less than 20. In x1 less than 20, you have another split decision. That means x2 greater than 200 or less than 200. So here x2 less than 200, if it is yes, means you have some data points, and here no, you have some other data points. So like that, you will have a tree format. This is called decision tree. That's why the algorithm is called decision tree. If you have more split there in the algorithm, yes, it is there. You have another split that is called split 4, where it occurs is x1 greater than 20 and x2 less than 170. Let's see how it is happening. Less than 170, yes, and then x1 less than 40. Again, you have two leaves, yes and no. So like that, a tree, decision tree has been formed based on your data set by using the algorithm. Okay. After that, what will happen is it will create an average. Okay. So the values of these data points are put together and the average has been taken, and that average is 0.7 here. Similarly, all the data points averages here is chosen, is calculated, and that average is 1023. Here, all the averages of these data points in this leaf has been taken, and it is minus 64.1. Here, all the averages has been taken, and it is 300.5. So like that, for each and every leaf, we call it as leaf. Okay, the average has been taken, and that value has been fixed to that data points. Okay, so the data points inside this leaf has the values called minus 64.1. Okay, so like that, the values has been fixed to this data points. So this is the working of decision tree algorithm. Okay, so in the previous case and all, it is not like that. We will apply the sigmoid logistic regression. We will apply the sigmoid function into the data set, and that data set is classified based on the probability. But here it is not like that. We will split the data sets and then we will take the average of that group and we will fix the value. Okay, so now we can see for this group the value is 300. For this group the value is 65.7. For this group the value is minus 64. Like that, the values has been fixed to this data set. Okay, in normal case we will not do like that. We will take the average of all the points. Okay, we'll take the average of and then we'll predict the results. But here we'll split the values, split the data sets, and then we are taking the average. So by doing that, we are increasing the accuracy. We are getting better accuracy in the decision tree algorithms. So that is the working of decision tree algorithms. So keep in mind, initially the library function you have to import, then upload the data, and then analysis the data, pre-process the data if it is needed, encode the data if it is needed, and train and split the data, train the model, evaluate the model. So that is the usual procedures in the machine learning. And first step is connect the Google Colab notebook with the server. Once it is connected, first is importing the libraries. 3 main libraries we'll use always. Import NumPy as NP, and then import pandas as PD, and then import matplotlib dot pyplot as PLT. So we want, if you want Seaborn, we can use for analysis purpose, but here I'm not using it. And then run it and upload the data set. So the data set that we are interested is gold price prediction. Very interesting data set, that one. Once you upload that, copy the path of that file, close it, and then open the command. The name as data set for the that variable. PD is the pandas. Read underscore CSV. Open the quotes, and you can see there is a tick mark. Now the data has been loaded. The next step is we need to analyze the data. Okay, we need to analyze the data. You just open the, double click it, analyze the data. We want to see what are the things that is in the gold price document. As usual, we know the function dataset dot head. It gives the first 5 columns of the dataset. Here you can see date, SPX, GLD, USO, SLV, and Europe by USD. Okay, so these are the parameters that is used to find out the price of the gold. Okay, so GLD is the gold price. And what is SPX is? It is the top 500 stocks in the stock market. Okay, that is the SPX index. Okay, top 500 company stock market. And USO is United States oil price. SLV is silver price. Euro divided by USD is the Europe currency by USD. That means how much euro is for how much euro. So that means 1 euro is 1.47 US dollars. So that is the ratio. Okay, wait a minute. I have to allow one. Okay, so these are the data sets. Okay, next we want to see the tail. How many data sets are there in data points are there in the data set? So that means we can have shape also we can use to see how many rows are there. So you can see there is 2290 rows and you have 6 columns. So it is a huge data. So we are interested in the gold price. And what are the features that you are going to consider is SPX, USO, silver, and the ratio of Europe versus US dollars. Okay, so that are the things we are going to consider. Okay, now the next step is if you want the information, more information, just we will check whether it is there any null function or there. Because if there is any null function, then your prediction may go wrong. That's why the data cleaning and pre-processing is very much useful. So what is the function to check the null? Data set dot is null. Is null means it's saying everything false, 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 false means. So if you want the count means just give dot sum. It gives the summation of all the columns. That means all are zeros. False means 0. That means there is no null in the data set. So it is a clean data you can use for algorithm. Okay. The next step is we want to separate the independent and dependent variables. We know what is independent variables and what is dependent variable. Dependent variable is the target variable that we are interested in, and independent variables are also called as features. So what are the things that you are going to consider to predict the target? Okay. So for that, we have to give the variable capital X equal to data set dot drop. That means we are going to drop the columns. Okay, open the quotes. What are the columns that you are going to drop? Okay, you can see in the data set what are the columns that we are going to drop. We have to go forward. Here you can see I no need date because it is a date of price. So it is from 1 to 2008 to I think 2012 or 2013 years. So database. So I don't need the date. I'm interested only in the features. What are the features? SPX, USO, SLV, Euro. And this is the output. This is the dependent variable. So I'm interested in the gold price. So I'm going to remove GLD as well as date. What I'm going to do is I'm going to drop those columns. What is the column? First column is date. So I have to give the variable name correctly, or else it will put the error. And then axis equal to, so that means the column, the entire column I have to remove. Just run it, it is showing the error because I am using the, I have to use the, so in case if you are finding any error like this, okay, I know what is the error, but I will tell you if you are finding some error, just go to ChatGPT and then paste that error. Ask the ChatGPT to explain it. It will explain the, so what is the problem. So what is the problem? I have not used this square bracket. So it's showing that. Okay. So just go back to the code. So this is how we have to. Okay, sometimes we may forgot to do that. So just copy this line and then paste over it, or you just change the thing. No problem. Again, if there is some error means we have to do it again. Okay. And we have to do the axis 1. Axis 1. Axis equal to 1. Now run it. Okay. Now these two columns are, and another one is y. So that is the dependent variable. Again, the data set we are going to take and open the square bracket, open the quotes, and what are I'm interested only in the GLD. So now we'll see print X contains all the rows except date as well as GLD, but it has the 4 features here. And why it's showing error is small y I have used there, and here it is. So now we can see the gold price is in the target column. So this is how we have to. And then the next step is splitting the data set into training set. So wait a minute, one person is waiting, just including them. Okay, now we move to the next part. So that's the data pre-processing. If you want to do any standard scale, if you want to apply some standard scales, we can apply. But I don't think it is needed here. There is some difference here, SPX values and USO and thing. There is some variations in the range also. If you want to apply, we can apply. Otherwise, we can leave it. Okay. If you want to apply means use the code that we have used before. Why I am not using is mostly all these are prices. Okay, it's a silver price, it's a USO price, and it is also a stock price. It is a Euro versus USD. So that's why I'm not using any scalar, any scaling. I'm not using scaling, and the encoding is also not needed because there is no character form. Now we have to split the train set and data set. We have the code for that. Okay, we can take the code. I have told you where to take that code before. So this is common code available in the sklearn. Just take it. So it is showing some error. The reason is here it is capital Y. Once you've done that, we can move to the model training. Where the model training, model data you have to take is, as usual, go to Google, sklearn, decision tree. Because we have two things. We have seen that two things are there. Decision tree regression is there, and decision tree classification is there. The decision tree regression. So we are interested in regression. So just go through that, and from here you can take. Okay, from these examples you can take. So we have lots of features here. I told that decision tree is working based on the entropy. So if you go through that, we will learn about this, how this is taking. Each and every feature they are explained. The decision tree class when example. So we go to the example and we will take the lines from this. Okay. So you have to search like this, and finally we'll find the see the program. Okay. Now you can see from sklearn tree import decision tree regressor. So this is the line we are interested. And then one more line is there, that is regressor decision tree random state. So just copy that line. This is the library function. And then go back to our program, open the code and paste over here. And we have to create one variable called regressor. And we have to put, we will go back and take, no problem. And then random state 0. So this is the line. Okay. Now just run the program. Now your regressor has been formed. The model has been created using the regression tree. The next step is model evaluation. That means we need to find the test. We have to use the test value to predict. So next step is train. We have to train the model. After that only we have to evaluate. So all steps are common. There will be no change. Only thing is we need to change the model training, and the data pre-processing will change. Will get some changes. Other than that, you will not have any changes. Next thing is R-square metric. Just take it and put over there. I've explained already what is this one. Okay. We see the R-square error is 0.98. Okay. So that is error score. So if you want to learn about this R-square, again, you can go to sklearn and you can learn. No problem. Okay, it is a metric. So it is a good accuracy here. Okay. 98.5. And then we have to, we can see in the plot also. So that's why I'm converting y test equal to list. List means you're converting array into list, and then I am applying the graph. I will explain the graph afterwards. You can see the actual price as well as the predicted price are almost there. So there will be small variation, but we are not able to see the difference. Okay, we have taken the y test color as blue, actual value as blue, and test prediction as green. Okay, and we are doing the actual price which is produced. These are the labels. and legends there, and then plt.show means is showing the graph. When you put plt plot, the plot has been created. Simple as that. Okay. So we can see it is almost mapping the blue lines. So it is very good performance. It has very good performance. Okay. If you want to see the new values for the prediction, we can have the input values, and then we can create the. So this is all about decision tree algorithm. Okay. So this is all about decision tree algorithm. Okay, it's very interesting one. So I've told why it is having more accuracy means we are splitting the data and we are calculating the average. We are not calculating the overall average. We are calculating the average of a particular leaf. So that's why the accuracy is more. Okay. It's another interesting one. This is called ensemble learning. This is called ensemble learning. Ensemble learning means taking the same algorithm multiple times and making a powerful algorithm. Okay. For example, in a particular data set, we are applying one time the algorithm, and then we are calculating the result. Instead of that, if you apply multiple times the same algorithm into the data set, you will have more stable, or it becomes more powerful. Okay. So that is the basic idea. Ensemble means that is the idea behind it. Okay. For example, here you can see we will take a data points from the training set, and we are building the decision tree associated to this data points. After that, what we are doing is we choose n number of trees. N number of tree. In a decision tree, we will use one tree. But in random forest, we will use n number of trees. And then we will calculate the output of each and every tree, and we will have the average of all the values. And we will come to the conclusion. Okay, so that is the basic idea behind it. So instead of having only one decision tree and predicting the output, what we are going to do is we are going to apply the same algorithm multiple times into the data set, and we will have the different outputs. That output average has been taken, and that is your predicted output. Okay, so that is the idea behind it. Okay, it's like a forest. Why it is called a random forest means in forest you have multiple number of trees, isn't it? You will not have a single tree, you will have multiple number of trees. The output of all the trees are combined together. We will take the average, and we will have the predicted output. Okay, so that is the basic idea behind it. Are you able to understand this? So instead of one tree, we are using multiple trees. Okay. So the other ideas are all same. Decision tree is how the decisions are taking place, and splitting of data. Everything will be same. Only thing is, instead of one time, we are going to use multiple times. Okay. So that is the random forest algorithm. Okay. Now what we are going to do is we are going to create a random forest for the same data set, and we are going to see the result. Okay, here already decision tree itself 98 percentage accuracy is there. So here by applying the ensemble, we will see how much accuracy we are increasing. So the concepts are same. Okay, so already have the data set. The changes will be there only at this point. Only at this point. We'll, as usual, we'll make a copy of this one. So do it again. Okay, the main thing is here. I'm just deleting that. I'm going to tell you what is that. Okay, how we are going to get. So you can use the sklearn for that. So all these are common. So I'm not going to do any change here. So we are using the same algorithms, same libraries. So first, before that, we have to connect. When you connect, it gives you the suggestions. First part is connect your collab with your server. Now you can see it gives the suggestions for us. Upload the data set. So we are going to compare these two. That's why I'm using the same algorithm, same data set. You can try different data set also. Data set equal to ed dot read underscore CSV. To read the CSV file, the name of the CSV file you can take from this location. You can see copy path. Just copy that and paste. Open the colon and paste it. I already checked head detail, everything we have checked before. So I'm going to split the rows and columns. Features and targets. This is the place for that. Capital X equal to data set dot drop. I'm going to drop two columns. One is date, another one is gold price. There is there, behind it is there. So the same thing only. Okay. So it's there. So I'm just going to drop it. I'm showing some error because it is small y. It is showing is I'm not using column here. So the reason is here I use a data set. Here I'm using gold data. Here also data set. So this is the modification that I did. Okay. So it will show some error. Just we can see it. We are separating the features as well as y. And then we are splitting the data. Again, it will show it is splitting the x and y. No problem. Then random forest. How we are going to take this? Let's go to the Google sklearn random forest regressor, because we are going to predict the values, numerical value. Here you can have that sklearn.ensemble. Look at here. There you have sklearn.tree, but here you have sklearn.regressor. When you go down, you will have the example. From that, we can choose the lots of things you can see. Not only tree regressor, extra trees regressor, gradient boost regressor. If you want, you can try all the different types of regressors. Okay, it's our interest only. Then we have to put this random for regressor, and then second line is regressor. Copy this line. In that lot of things are there, isn't it? So here you can see a lot of functions and parameters are there in the random forest. In that you can see n estimators equal to 100. You can change this also, no problem. N estimated is 100 means 100 times it is applying the tree into the data set. And finally the average has been taken, and it will give the predicted output. But before that it applies 100 times. So by default 100 times. If you want to increase 200 times, 300 times, you can increase here. N estimators you can increase. Okay. So that's what I want to tell you. Here regressor, give the complete name because I have maintained regressor here. Random forest is a max depth. Max depth is another parameter. By default it is 2. Random state is thing. N estimator we will maintain here. N estimators equal to 100 is given. I am giving 200. Then run it. So if you want any information, I don't know what is this max depth and whatever it is, you just see here, they give some explanation or that, or if you put it in the ChatGPT, it gives you the explanation. You can learn. Okay, finally, we come to the end. This is the code. You have to predict the test value. and then see so it's showing some error. Okay, the reason is, we don't know the reason. So if you don't know the reason, it's showing something. I know what is the reason, but for learning purpose, how I'm doing is just put it here, and I'm just asking the ChatGPT to explain the error. So I missed the training part there. Let's see the ChatGPT is finding that or not. Yeah, it's finding. So you can see I am not trained the model with the X values. It's saying that. Okay. Wonderful. So I have to include one more line here. I missed that. The ChatGPT told me. Again, it's showing some error. Regressor dot fit X train Y train. What is that means? Here small y and here capital Y. You have to make it capital Y. Okay. Now the random forest has been created. Now we will predict the results. Okay, we take the test prediction. We got the values, some predicted values, and R square error. Actually, it reducing 82 point. Okay, the error has been. It's not giving the proper answer. Okay, so you can see lots of blue. Okay, it's not predicting properly. So let's reduce the ensemble to 100. Maybe I have given more training. So let's check that. So that's how we have to work on the machine learning for any data set. So again, it is 80. Okay. Not showing much difference. The max depth I've given 2, and it give that 0. Because by default, the max depth must be integer in the range 1. Okay, it is in the 1. Is there any improvement in the accuracy? So these are the parameters we can play with while doing machine learning. So it's reduced to 65. It's not working well. So the random forest regressor is not better performance, not performing better than decision tree for this data set, because there itself it's 98%. So it's maximum I'm getting 80. The reason is maybe overfitting because it is not following the blue prediction. So it is around this point. Okay, beyond that it is not following the randomness of the values. So that's the reason. It's okay. So the best algorithm for this data set is decision tree when compared to random. This may vary for another algorithms also. If you are using some other data set, your random forest may perform better comparatively compared to decision tree. So that depends on the data set. Okay, so that's all about this session, random forest and random tree.